Welcome to AI Frontiers. Today we explore a monumental snapshot of computer vision research from December 9, 2025. The field is maturing beyond simple recognition, tackling everything from brain scan analysis to wildlife conservation, video reasoning, and 3D world building. Our journey today unpacks 209 papers from a single research day. We will identify the dominant themes shaping the field, take deep dives into groundbreaking methodologies, spotlight 3 seminal research papers, and gaze at the horizon of future possibilities. Computer vision has evolved. It is no longer just about asking, "What is this?" but "What is its 3D structure?" The field is moving from passive perception to active understanding, bridging decades of signal processing with modern deep learning. It is critical for self-driving cars, medical imaging, and creative tools. The frontier now pursues holistic, efficient, and responsible visual intelligence. A major theme is the push for unification, building single systems for multiple tasks. MetaVoxel is one model for brain scan generation, age estimation, and sex prediction. UniUGP unifies scene understanding, video prediction, and trajectory planning. This moves beyond the zoo of specialized models. General-purpose visual intelligence requires unified world understanding, and the train-once-query-flexibly paradigm is emerging. The second theme is reasoning and controllable generation, moving from realism to reliability. Revise enables editing videos with physics-aware instructions like "make the person slip." Context drag preserves fine details in drag-based image editing. Generation is now about adherence to user intent. Models must understand cause, effect, and narrative logic, closing the say-do gap between understanding and action. Theme 3 is efficiency and real-world deployment, moving from server farms to solar-powered collars. LiM-YOLO is a ship detector redesigned for satellite imagery efficiency. Animal re-identification models run on microcontroller units. FastBev plus L plus achieves bird's-eye view perception at over 130 frames per second on automotive hardware. This is the bridge between lab breakthroughs and real-world impact, featuring extreme specialization for practical applications. 5 critical insights stand out. First, joint multimodal diffusion models enable train once, query flexibly, as seen with MetaVoxel. Second, high-fidelity 3D understanding is becoming efficient and robust, demonstrated by gains. Third, elaborate chain-of-thought reasoning may be unnecessary for video tasks. Fourth, a single-layer norm fix solves visual information loss in multimodal large language models, as shown by Lee and colleagues. Fifth, diffusion models can now generate infinite coherent landscapes with terrain diffusion. Progress is powered by a diverse toolkit. Diffusion models offer versatile generation, but are computationally expensive. Transformers provide powerful context capture, but face quadratic complexity challenges. 3D Gaussian Splatting enables real-time rendering with memory footprint trade-offs. Self-supervised learning offers data efficiency, but can have performance gaps. Each methodology continues to evolve to address its limitations. Our first deep dive is the paper Topological Conditioning for Mammography by Fanning and colleagues. It addresses the generalization crisis where medical AI fails across different countries and equipment. The solution uses topological data analysis for stable anatomical signals. Their method, wavelet persistence vectorization, creates invariant feature maps. The result improved the area under the curve metric from 0.55 to 0.75 on a Portuguese dataset. The significance is that classical mathematics can provide AI with robustness guarantees. The second paper is Revise, Reason-Informed Video Editing by Lee and colleagues. It tackles the problem of models struggling with physics and narrative-aware editing. The innovation is a self-reflective learning framework within unified models. The process involves the generator creating an edit, then the model evaluating its own work for logical consistency. This led to a 32% improvement on reasoning-based editing tasks. Its significance is as a blueprint for closing the say-do gap in AI systems. The third paper is The Unseen Bias in Multimodal Models by Lee and colleagues, a forensic architecture investigation. It discovered that visual tokens have higher vector norms than text tokens in common pre-norm multimodal large language models. This causes representational inertia, crippling cross-modal fusion. The fix was adding a single-layer norm layer after the visual projector. The impact was significant performance gains across multimodal and even pure language tasks. This represents a foundational architectural fix with outsized practical rewards. The frontier is heading in 4 clear directions. First, toward truly unified agentic world models for perception, reasoning, and action. Second, efficiency-first architectures for edge devices and real-time applications. Third, the integration of symbolic reasoning and physics simulation with neural networks. Fourth, the development of auditing, debugging, and safety tools as foundational research. This is the path toward transparent, correctable, and privacy-preserving systems. This synthesis was created using AI tools and a human review process. Content was synthesized using the GPT DeepSeek model. Text-to-speech synthesis was via DeepGram. Image generation used Stable Diffusion. All synthesized content underwent human expert review. A caveat is noted. While reviewed, some oversights may still exist. Subscribe to AI Frontiers to stay on the cutting edge of AI research. Join our community exploring the latest in artificial intelligence with weekly deep dives into groundbreaking research papers. We analyze emerging trends across computer vision, natural language processing, and robotics. Subscribe to our YouTube channel for video presentations and be part of the conversation shaping AI's future. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from the arXiv preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses arXiv preprint server content under its API terms of use. AI Frontiers is not affiliated with or endorsed by the arXiv preprint server.